Alright, let's see if you can figure this out. If you write it out, ladies and gentlemen, the first term is x. The second term is x plus squared. Then x cubed. Then blah blah blah. Ladies and gentlemen, if I tell you the absolute value of x is your phone on the table. Get your phone on the table. The absolute value of x is less than 1. Doesn't that mean that the absolute value of r is less than 1? Therefore, I am converging. Doesn't that mean that I can do s sub n equals a sub 1, that's x, over 1 minus r? Easier than I thought it was. X over 1 minus x. So what a is considered the first term. This is a sub 1. This is always a sub 1. It's not a, it's a sub 1. So what is the first term? We used to get 1. The first term is x. That's why I kind of why I wrote the first couple terms. What's happening? You're multiplying by r. That's why x is r. A sub 1 is x. Yes.
When you're applying the test, is the x plus x squared was like the third test?
No, the test is the geometric series. Absolute value of r is less than 1.
So
that's the test.
So it's left side of work then?
Yeah, the left side is just work. You literally didn't need this. I needed this. This is what I needed. I needed the red.
Okay.
I actually didn't need the blue. The blue, I just wanted to show you where the series were.
Okay.
So would you have to say that x is equal to r?
Yes, you would have to say that r is x, so that you could tell me that the rate, what r is, and r absolute value of r is less than 1. Yeah, you had to define what r was. All right, ladies and gentlemen, ready for the next one? Show that. Where is my mouse? There you are. Show that this series is convergent and find its sum. Go. Correct. The first term is literally plugging in what n equals 1. So there's my series. The question is it convergent and find its sum? So the first thing, so I gave you the hint of what? Partial fractions. I wrote it out. That's not, they're definitely getting smaller. So it's probably going to converge, but that's not helping me in terms of saying that it's convergent. I can see that the number is getting smaller, but it's not helpful in terms of finding it. So, I gave the hint of partial fractions. Because it says nicely for partial fractions. Partial fraction decomposition. Partial fraction decomposition. Find me A and B. Out now that this is the same thing, the summation of n going from 1 to infinity of 1 over n equals negative 1 over n plus 1. Everyone okay with that? Huh? I'm actually not going to split it up. I actually want to talk about doing some numbers. Now do some numbers with this. Now do some terms with this. Don't add them. Literally leave them as separate fractions. What'd you say, Sarah? How's happening? You're right. Ladies and gentlemen, please note when you write it like this, what do you notice? Things keep. Yeah, that cancels out. That gets this and this, this and this. This won't cancel out with the next one. What's it gonna equal? Why? Ladies and gentlemen, this is considered a telescoping sum. So therefore, it is convergent. Now, you do realize, as you continue on here, right, you're going to have and 1 over n minus 1 over n plus 1. You're eventually going to be left with the limit as n approaches infinity of 1 plus 1 over n, which is 1. Because this is going to cancel out. The last thing that's going to be left is this 1, and that 1 over n. So therefore it converges, and it converges to what? 1. So this is one of the ones, again, you notice that we're using all of your information on putting it all together. We're always like stuff from unit 1, stuff from unit 3, stuff from unit 3, stuff from unit 6. I'm pulling from everywhere. No, this is 1 plus 1. This is that one that was sitting there in front. Because that one that's sitting there in front. Yeah, the 1 over n is 0. Yeah, because that one, that telescoping sum, that one's still sitting there. All right, we okay with that? I got one more to do. We are showing that the harmonic series is divergent. We are showing that the harmonic series is divergent. Well, let's talk about the harmonic series. Please write me the harmonic series. Yes. Yes. No, I can't do this yet. We actually can't show the divergent because I need to use comparison tests, and I don't have the comparison test yet, so I can't do this one yet. Sorry. Thought I could do this one because I haven't talked about comparison, so I can't use this one. So hold that. We'll do that next class. Well, class after next. I want to talk about some comparison because I forgot I can't do that. Okay, hit the wrong thing. How do I show that this series diverges? How do I show that this series diverges? Not controversial. What limit can I do? Oh, so perhaps I should write the limit as n approaches infinity of this series, or of this function. Let's try that. So I had two people that said, perhaps I should do limits.
Oh, you divide it by L. What was the power?
It's the ratio of x.
Answer? So 0 says the limit as n approaches infinity of this function does not equal 0. Therefore, the series diverges. That's the contrapositive piece. That's the contrapositive piece. Everyone okay with that? Okay. I'm going to stop there. What I want you to do is I want you to pick up the packet that you got.